Okay, we're live. Hey everybody. We're back again, second live stream of the week, and I'm here with Epic Games audio lead Aaron McLaren. How's it going, Aaron?
Everything's great. We've
Yeah,
just been chatting for like 30 minutes, so it feels strange to just switch to live mode.
that's it. That's it. We've switched. We've hit the switch now, and now we are here. And this is really exciting, and I really appreciate you taking the time to show us this really awesome new tool that's really going to help audio programmers around the world. And we're
And
going
hopefully sound designers and
That's right.
composers and musicians.
That's right. That's
Yep.
right. Uh, so to I think it might be helpful for us to do a little introduction to talk a little bit
hmm
about yourself, your background, maybe talk about Unreal, and then we can go
Yeah.
on to MetaSounds.
Sure.
So maybe we could start with you. So can you just tell us a little bit about yourself, a little bit about your background?
Yeah. So I have a little bit of an interesting pathway into games and audio programming. My background is physics and music. In my undergrad, I graduated high school in '98, so I'm 40 now. Uh, and I studied physics. I was really into astrophysics, but I was also really into music, and I was a dual music physics major for a long time. I ended up switching at the very last minute to get more physics classes in, so I only have a music minor. And then I went to graduate school in physics, so I got a master's degree in physics. And I was intending to get a PhD, but it was there that I had the fortunate opportunity to have a buddy of mine who introduced me to computer music, which kind of like melded all of my interests, music and math and all that stuff. And I got a book called The Computer Music Tutorial by Curtis Rhodes, which I recommend. It's a little old at this point, it's like 20 years old, so it's outdated. But at the time, it was like, what? This is even something people do? And I at that point I switched from thinking about physics all the time to thinking about what I could do with sound and music. I mean, I would like wake up in the night going, "Oh, I bet I could do this," and I'd go and start messing with stuff. C sound was what I first started digging into stuff, which I would recommend. It's a lot of C sound is kind of it's a programming language for audio and music, and there's a lot of progenitors out there. It's a progenitor for a lot of other things after C sound. Um, and then basically I left physics graduate school, became a high school teacher for a couple years, about 3 years. I taught high school physics and calculus, and I also taught a class on synthesis programming. I taught a class in Reason. You guys know Reason,
Oh yeah.
and which was fun. It's an elective for these high school kids.
And
And
what year is this?
this is 2004 is when I left. So I graduated college in 2002. 2004 is when I got my physics master. So between 2004 and 2007, I taught high school. And when I was doing that, I was like basically like a mad scientist at night and during the summers. We had the summers off. I would just be building skills on music and programming and stuff. I took a summer course at UC Berkeley. By the way, this is in Sacramento, so I taught high school in Sacramento. So I went out to UC Berkeley for a summer workshop at CINMAT, the Center for New Music and Audio Technologies, which is a little thing that they do every summer. They put on like a sort of a Max MSP sort of what do you call it, like a little week long clinic or something. So at that, I took one. I actually did those I think 2 years in a row. But the first year I did it, I met all these people working at Max's, which was down the street from there. They're in Emeryville at the time, which Emeryville is really close to Berkeley. Um, anyways, so I just hung out with them. I recommend in general if you meet somebody doing something cool, don't just be cool. So I wasn't I mean I grew up playing Maxis games. I'm a huge Maxis fan, and so it was a little bit of like, oh my god, these people working on Maxis. What they're working on Spores. So they were all the Spore was in development at the time, and I had read about it, and it was so cool to like meet people working on it. But I played it cool. And after hanging out with them, they invited me to come out to their studio later that whenever, and I had the summer off, so I was like, yeah, I'm down. And there I met the audio director, Kent Jolly. We hit it off pretty well, and that was it. It was like a Mr. Rogers seeing the sausage for me. I was like, oh, that's cool how games are made. Went back to my high school job. And that's the other thing, by the way, I recommend to people when you start getting in your career, like be cool with people that are starting out because you never know what's going to happen in the future. Somebody who's totally new, in 5, 10 years, may be the lead audio programmer on something like
Or
Unreal
maybe,
Engine, and like it could flip. So you
yeah.
never know. You never know what's going to happen with people's careers. So, anyways, he invited me afterwards. So later, I kept working on some projects, and I wanted to go to graduate school again for computer music. And I sent Kent my project just to get advice because I was about to apply to graduate school. He replied with some good advice and a job offer to work on Spore. So that was my first game job. Was basically assisting Kent on Spore, and I got to work with Brian Eno, who's a famous. Yeah, if you don't know him, he's famous. And totally was not the intention when I took the gig for anybody involved, but I ended up doing a lot of the procedural music on Spore, and I get my first GDC talk was in 2008. Thanks to Kent's generosity, he split the bill with me, so we co-presented on the procedural music we worked on, and that kind of launched my career in games where a lot of well-known people in game audio were like, "Oh shit, who's this young whippersnapper?" But after Spore gig, I went back to graduate school, and that's where I really got deep into programming. That's where I learned deep C++ shit. I worked with Curtis Rhodes, who's a luminary in computer music, the computer music world. He was my hero. He's the guy that wrote computer music tutorials, so I was very honored for that. And then I went back into games after that experience as a sound designer on Dead Space. And at that point, though, I had pretty serious programming chops, and decided to just become a programmer. So that's when I started working at Sledgehammer. I got to work on Call of Duty titles, and then after that, Guild Wars. I got to work on Guild Wars 2. Then 6 years ago, I landed my gig here at Epic. So, and then we can talk more about that. But that's my career. It's kind of crazy. That's how it started.
That's amazing. And you pointed and you did make a couple great pieces of advice for audio programmers who are just getting into the industry. So could you talk a little bit about that? What would you
Yeah.
give what sort of advice could you give to people who are just trying to get into this business?
Yes. So the thing about programming that's hard, there's a lot of humps. There's many humps in programming. And there are different kind of humps. You know what I mean? Like you open up. The very first one might be just figuring out how compilers work and how to actually compile code. Like, oh, this seems cool. How do I get this to work? I think my first real struggle with programming was I had a professor who was like, "All right, make a synthesizer, make a sign generator in pure C uh, with port audio." And port audio is like it's like a API for interacting with hardware. And I remember that weekend I was just like, "What is going?" I couldn't figure anything. I didn't understand pointers. I didn't. So it was just like that. Like one weekend, it was like all of these crazy hurdles. And I would say that you just got to stick to it. I call it being an intellectual bulldog. So bulldogs are these tiny little dogs, and they call them bulldogs because they take down bulls. And the way they do it is they grab on to the like nose of a bull and don't let go and tire out the bull. And the bull's just like, ah! You're like, no, I'm not giving up. And then at some point, the bull slows down, and then the bulldog wins. So if you're an intellectual bulldog, you just grab it and you don't stop, don't give up, just keep going. You might call that discipline, but I just call it not giving up. Just keep going, and you'll keep running into hurdles. And even after a point where you're a good programmer, or you've got a lot of experience, I should say, no one's really a good programmer. Like you've been there so many times, you're like, this might be the problem that will destroy my career. That even happens to me all the time, right? Like I'll finally be exposed that I don't know what I'm doing. Uh, anyways, just keep going. Don't like ignore that fear. Ignore that you might another kind of monkey mind. Just ignore it. You know, uh, find help. Be cool when you look for help. I saw you actually posted a really good Josh on your Discord. I read it. I shared it with my team, by the way. Um, how to ask for help. It's so useful. It's such a useful skill to learn how to ask for help because everybody needs help. It is okay to ask for help. Everybody needs it, but you have to learn how to ask for help because people are busy. Even the generous people who give their time to help people, they are still busy, And so you don't want to be rude. You want to actually put in some work. You don't want anybody to do anything for you. No one's going to hand you a silver spoon and say figure it out, or not, and say you don't have to figure it out. Let me just do it for you. So, anyways, that's my advice. At a very high level, don't give up and be cool.
Yeah, be cool is a good one. Yeah, that's great advice. And I thought that'd be great to hear a little bit about your entrance into Unreal Engine,
Yeah,
how you got the role,
that's
a
good.
little bit about
That's a
your
good question.
career journey with that as well.
So, this is actually a really good question. I'm really into audio programming at like really into it. I really like audio programming at all levels, low level to high level, to making tools, to just make. I love making sounds. I just all of it. And once I had some experience under my belt, I started developing my own ideas of how it should be done, and it was kind of frustrating because usually, if in a professional context, you jump in and it's like 98% of it's done, and you're just up here on the top, kind of floating on leafy features and fixing bugs, and you don't ever really get an opportunity to really try out ideas at a low level. And so on the side, when I was a programmer at Guild Wars 2, which by the way used Fmod under the hood, um, it wasn't Fmod Designer, it was the Fmod low level, which they call it now, and then it was this whole engine on top of that. But I didn't design it. There was a previous programmer, and I was just learning somebody else's engine. So I was like, I want to build my own audio engine. So on the side, as a private project, I built an audio engine in Unity. I never shared it because at the same time, that's when Fabric came out, which is basically the same thing. If you know Taz Anastasio Bracas, who worked on Fabric, like he beat me, and he was way more put together. His whole website, whole infrastructure, and I was like, oh, I'm not going to compete with that. But I had learned Unity, and I built the whole audio engine, and it was a fun experience. And then that's when UE4 came out. Like literally, it was because Unity was big, and then UE4 came out, and I was like, all right, I'm gonna do what Taz did for Fabric. I'm gonna do an Unreal. I'm gonna make my own audio engine and sell it as a side thing, right? So I dug into Unreal and I started learning it, and then it was uncanny. I was like 2 weeks into that project when I don't even know if how it happened, but my LinkedIn got flooded with people from Epic. It was like I went over to LinkedIn, and it was like 20 people from Epic are looking at your profile, and I was like, what the hell happened? And then I got a call from a recruiter and like we want to hire an audio programmer. We think you'd be good for it. Do you want to talk? And then that's how it happened. So, and that was through a chain of it turned out after the fact. It was recommendations, which is actually a really good story. I should tell you. So I'll tell you. I'll be totally open and honest. I applied to Valve, which was my dream company to work at. I love Valve. I still do. And I was like, I think I can do it. And I was like, I have like 3 years of experience in games. I can work at Valve. So I applied to work at Valve and I got the interview. And I even made it through the whole day. Valve is famous for like cutting people and like walking them early on. So I'm proud to say I made it through the whole day for the Valve interview. But at the very end, they're like, you don't have enough experience. Sorry. So I totally missed the Valve job. Retrospectively, I was very junior. Relatively speaking, I think for what Valve needs, and which is what they said. They're like, our environment, you have to be like a super senior. No one's going to help you. It's sink or swim here. And they're like, you may succeed here, but it's hard to tell. It's hard for us to get rid of people. so, so we always were really conservative about hiring, so I respect that. But apparently, I impressed somebody in there, Mike Moraski, who is the one of the I don't know they don't he's an important audio person at Valve. They don't really have titles, so. Uh, Anyways, he's friends with the audio, or not the audio, but the tech director at Epic, Kim Library. And Kim wanted an audio programmer. Talked to Mike. Mike said that I impressed him in the interview. So it was like I lost the Valve job from that interview, but got a recommendation for the Epic one, and that's how they found me. So even if you get turned down and you don't make your job, don't give up. One door closes, another one may open. In retrospective, I think Valve or Epic was better for me and what my ambitions were than what Valve is because I'm in a position here where I can make a bigger impact. I think on the game industry. It's been a while. It's 6 years, and I think we're finally starting to get to the point where we can actually start doing the bigger vision stuff that I've been trying to get to in my career. The whole reason why I'm an audio programmer. So,
Amazing. And for people who may be just getting started, how would you describe an audio engine for
oh,
people
that's a
who?
really good. So, this is a really good question. Your audience, it seems, I ghost a lot on your audio programmer. I'm big into Juice, by the way. I learned Juice programming as well, like way back when Juice was when it was like, how the hell does this work? There's like no document. It's amazing. Like learning Juice now is so easy than it was in like 2008. Like it was really hard to figure out in 2008. Anyways, I was building Juice VST plugins and shit way back then, and uh, my point is that if you have that kind of experience, what I would characterize a game engine is kind of essentially like a sampler. So in the world of VST plugins, you build a sampler instrument. So uh, let's say you're trying to build a keyboard sampler. You have all these things mapped to different sounds. It's a whole bunch of different sounds. You have to worry about memory management, just like you do with samplers. You have to worry about latency. You start thinking about streaming and stream caching, all this shit for like a really fancy sampler, like a really high-end sampler. These are all things like sound designers often have to have shit tons of RAM because of all the sampler instruments that they got in their DAW, right? You might have like 12 samplers, and each of those samplers is like a freaking gig of samples. Like every possible gesture. Like if I do it lightly, it's a sample. If I do it a little bit harder, it's a sample. And this one, and it's this really complicated thing. You can start getting into all this crazy stuff. So what you can think of for games is like a really ultra complicated sampler, where polyphony is just like it is in your sampler. You're like, how many voices do I have? And then what are the rules on voice stealing and all this kind of shit. And then similar, like you got a project with tons of different samplers running. How do I mix that? How do I deal with the complexity of that? How do I manage CPU resources for my and then you shift that kind of architecture into a real-time context where you have to make this thing ship at scale. You don't know what the end users got, especially in the world of PC. This is one of the nice things about consoles is that that the end user has this hardware. But for PC, it's like, how do we dynamically adjust performance and it's called auto scaling and stuff like that. So I would characterize an audio engine as a really complicated sampler, procedural instrument sampler. So if you get deep into building samplers, almost all of your stuff, not everything, but almost all of it can map to audio engine. And then layer on top of that this idea of simulation and space and spatialization. It's like auto panning, you know. So when Dolby started coming out, by the way, this is actually an interesting story. So the Dolby Atmos stuff is that that actually started. I'm friends with one of their tech people. It started as a game thing, and games in their early days were like, yeah, that's what we do, like object-based spatialization. Hello, that's yeah, we have a sound source, we attach it to an object, and it moves through space. Welcome to 1998, you know. And so then it moved over to film and it got a huge thing, and everybody's like, whoa! In my DAW for linearity, I can attach this source of the thing, and then when it moves across the screen, it'll pan automatically. And so now Dolby Atmos is funny. It's like back into games is this really exciting thing, but like games have always done object-based panning, you know. So, anyways, I could talk forever about it, but that's in a nutshell. It's like a sampler, fancy ass sampler.
Wow. And how long has it how has so you have the audio engine and then you have MetaSounds. So
Yeah.
how do those two things connect? So if your
So
audio engine is like a mega sampler with all of these different considerations that you need to make as a sampler, how does MetaSounds play into that?
it's a really good question. So another way that audio engines are similar to DA. So the sampler is a big, another, I should say sampler is the problem space is similar to a game engine. Another way that you can sort of make a bridge to non-audio people is to think of each of the channels in a DAW script. Like when you here's the sounds that are playing through here. Here's the sounds that are playing through here. So what that is analogous to is a submix graph or something similar to most game engines have something like that. So just like you're in your DAW, you can sort of say the output of this goes to the input of this channel. That creates a graph, even though they're laid out in parallel. They're really just a graph. And so in UE, we have this concept of a submix graph, and it is literally a graph, but in your mind, it's the same kind of a thing that you might have in your DAW. And each of those channel strips can be thought of as sound sources. So when you go to, like you can have many different tracks sending to one of the channel strips in your DAW. the output of that would be like a sound source. And so like a sound cue or a metasound would itself be a sound source, which then can send its audio to a submix. And so a metasound is essentially a procedural sound source, like a sound source that's audio is being mixed and generated dynamically. It's not just play a sound wave, it's generate this complicated thing, but architecturally it's just another sound source. So it actually, MetaSounds plugs, if you, many in your audience may not know our pipeline or feature set, but it basically just plugs right into our existing architecture, like because it's just a sound. In fact, all of MetaSounds was implemented as a plugin, a UE Unreal Engine plugin, because it's been a while. Like I could talk about it in code in a second, but we've had the ability for anybody to create any sound source. We actually call it Soundwave Procedural. It's procedural sound source. So any plugin has for years now been able to make a plugin that generates any audio. And I've always said flippantly, you could build a whole other audio engine with this. And that's what MetaSounds is. It's like a whole audio engine to generate the audio of a sound source in a plugin.
That's really cool. And would you like to give us an introduction
Yes.
to how that actually works?
All right. So let me launch into my thing here. I got slides and stuff ready to go.
Aaron's even prepared slides for us.
All right. So let me see. Here we go. Here we go. So I'm sliding or sharing a portion of my screen. So so this is MetaSounds behind us. I'll tease it. So here's MetaSounds working. Got a little demo sent patch. Y'all hear it? All right. So let me just before we get into the fun stuff, I just want to kind of give you a little bit better of an idea. So we have this idea of an audio object. So first of all, UE5 is coming out. We have a lot of features. So I'll talk about MetaSounds in depth. We've got all kinds of stuff coming out. Quartz, audio modulation plugin, which is a new direction, and stream caching, which is boring but a very powerful feature for games. So there's this idea of an audio object is a huge idea in games and game engines. So this is sort of what we were talking about earlier, where it's like you don't just play a sound. This is sort of this. You could think of this as the sampler. So an audio object is sort of an abstract representation of a sound. So when you say in a game like play this explosion, the expression in sound of that explosion can be a complicated sound system, like an actual object. But conceptually, the game might say, here's an explosion in space with this amplitude, with these particular parameters, this relative direction from the listener, behind this wall, all these kinds of things. But in the end, it's like an explosion. And you might, if you're, you might imagine VFX have a similar thing. We think of explosion, but the actual particles and visual effects are something quite complicated and data-driven from a game. So in UE4, the audio object was called a sound cue. There's lots of limitations for sound cues if you're familiar with it. I won't go into details. But MetaSounds is the intention of UE5's audio object, so it's going to replace sound cues. So the idea is that every application from really boring, well, I wouldn't say boring, I'd call them bread and butter use cases of like, play this sound with these variations, even just play this exact sound the way it is, MetaSounds will handle all that.
So if I could stop you there for a second.
Yeah,
so
sure.
would you say that an audio object is the sound itself plus all of those extra things encapsulated, or no?
The audio object is a higher level construct that contains both the what you think of it as like the use a fancy word, the ontology. Like what does it mean? Like what is it? It's an explosion, and then also the concrete expressions of what that higher level idea is. And it could be just like a footstep. It's just like here's 8 sounds randomly picked from one, or it could be something far more complicated. So an audio object it's as complicated as a sound designer wants to get.
Okay.
And it can be as simple as here's an event, here's a plays a footstep, or it can be as complicated as here's a footstep, here's material, here's the boot you're wearing. It's you're in mush, the wind's blowing hard, and it's this type of creature, and the creature is in mating season or something. Like whatever the hell you want to input to the data, to drive your sound, you can do that. And so it's unbounded of what it means, but that's supposed to encapsulate everything that would be required to express a sound. And by sound, I don't mean like this sound wave. I mean like literally the thing that hits your ear, like whatever that means.
Yeah.
uh,
Yeah.
the cool thing about MetaSounds is that the power of it is that it takes this sort of idea of an audio object and then expands the potential to enormous. The potential is endless because it's a user customizable audio rendering graph. At the very end of the day, it's like max MSP. It's like you know, it basically allows you to do whatever you can think of. And that's the power of it. A couple of features about MetaSounds which I think are particularly unique is that the MetaSound itself is rendered asynchronously, so it's not in the actual audio renderer thread, or even on the game thread or anything. It's rendered in a just a task that's just a background task. So we have a thing called a task graph or a task manager that can take a bundle of work and figure out where to put it. So if you have a multi-threaded processor, it can schedule it and figure out, oh, this processor over here has got some free time. Let's slot it there. And so we just say, here's some work to do. Go figure out when and where to do it. And all of the sounds are rendered, in parallel at the same time. All the meta sounds. The Because of that, each of the actual rendering of the meta sounds are independent and unique in terms of the higher level like audio rendering parameters, like the size of the buffer, the sample rate, things that you would normally associate for the entire audio renderer. Is actually unique and individual for each of the meta sounds. So you can think of it as sort of like each meta sound is like a mini audio engine that can be tuned at runtime dynamically. So you can imagine a meta sound that has low priority really far away could be rendering at a lower sample rate at a much higher, block rate. And as it gets closer, you could potentially change the sample rate. This is a little aspirational, but because of this, that supports that type of thinking and that question: can we do that? So MetaSounds is early access. I want to emphasize. So some of this stuff is like there's like the core architecture is done. We haven't implemented yet a unique render block for every MetaSound, but it's like a day of work to do that. And then the other really exciting thing, and it can't be underscored, and I probably should put this at the first bullet, but this is something that is unique, I think. The only other domain that is similar to this is Chuck. I don't know if you guys have you heard of Chuck
Yep.
as an audio programming language. So Chuck allows you to get arbitrarily precise timing, and it's really powerful. Although I don't know if their Chuck is performant, but they also have this, by the way, they call them shreds. each thing can be a separate task. Actually, I don't know if they're async, but anyways, we have sample accurate triggering. So I'll talk more in depth this, but we can get timing down to the individual sample, which is pretty rare in the context of an audio rendering DSP graph, and I'll talk more about that. And then we've built it fundamentally extensible to plugins and third parties, which should be particularly exciting to you and your audience. And the way that we sell this to non-audio people is that it's like the material graph and Niagara in Unreal Engine. So what that really just means is audio shaders, if you know about graphics. If you don't know about graphics, it's a thing. Graphics people are like, aha. Like all of this, they're like, their eyes roll back and they're like, whatever, I don't care. And then you're like, it's like shaders for audio. They go, what? That sounds cool. So, pro tip also in your career, figure out ways to talk to people outside of your discipline to get them excited about what you're doing. This is how you do it, how you communicate what MetaSounds is to other people that are not audio people. The other kind of exciting thing is we have this document model. MetaSounds actually is decoupled from the Unreal Engine. So the graph itself is represented as a JSON script, or JSON, not script, but a JSON markup. The connections and what does what. So we could theoretically share a MetaSound easily over a network, copy and paste it between things, that kind of a thing. We have a graph editor, which I'll show in a second. Asset management. This hasn't been implemented in early access, but one of the big visions of MetaSounds, which is something that will make it work at scale by 5.0, which is in 2022, is the MetaSound graph should be thought of as a topology, not as an instance. So you build your graph, and then the input parameters are going to be settable by presets. So so the idea is you reuse your graphs as much as possible. So for example, on Fortnite, we analyzed by the way, Unreal Engine audio is used on Fortnite. In many games, there's lots of licensees who use our tech. But Fortnite's a great use case for like high production, high value. Like every 2 weeks, they ship tons of content. And so we analyzed all of the sound cues, the thing that MetaSounds are replacing, and all their topologies. We estimate a couple dozen MetaSounds would represent the thousands and thousands and thousands of sound cues on Fortnite. So that tells you something about workflow. It's like this graph represents guns, all
Mhm.
possible ways of playing guns. Okay, now every usage of a gun are presets on that graph. So that's the idea. And then we also are going to support MetaSound composition, so you can break up your graph into subgraphs. So if there's something that you end up using some logic a bunch, you'll be able to reuse that. Which to me brings into this idea of MetaSounds as a marketplace item in the Unreal Engine marketplace. So my hope is there will be people building amazing presets and selling those presets, and making money and sharing their cool stuff. And then of course the whole thing is supposed to be driven by gameplay really easily, which I'll explain in a second. So all of the input parameters they're automatically hooked up. It's easy to drive them from Blueprint, which is the Unreal Engine scripting language. In a nutshell, we believe, and I believe strongly, that the future of game audio is in procedural audio, and I mean that in the deepest sense. Just like graphics is procedural, when you build, graphics no longer is I'm going to go into Photoshop, make a texture, take that texture, import it into the game, and plaster it on a wall. Like that's not how games work with graphics. And games in audio shouldn't be I made my really cool sound on my DAW, I imported it, now I play it. Like we've been past that for a while, but I'm trying to push it even further in this idea of procedural audio. It needs to be the future. And that's just how things get interactive, how it becomes a rich experience as a gamer, but also other non-gaming experiences. I want Unreal Engine to be a premier place for aesthetic audiovisual experiences, art, aka. Anyways, so that's my sort of talk. I recommend if you are for non-audio people listening, or if you're new to audio, there's a bunch of stuff that MetaSounds. It's not made in a vacuum. There are other DSP graphs. I highly recommend checking them out. Maximus P is a really cool tool. It's unfortunately it costs money. So the free version is PD. Pure Data is phenomenal. By the way, I mentioned I worked on the music for Spore. Spore was done with PD, so I actually was paid in games to write PD patches. It was like my favorite job. I also recommend Chuck. I mentioned this. Notice they say strongly timed, concurrent, and on the fly. So they lead with strongly timed. It is a powerful thing in audio. Timing is important in audio, so sample accurate timing is a big deal. Capital B, capital D. The other one is Super Collider, which is my favorite audio programming language. I highly recommend checking it out. Like right here, they give you a demo of like what it might look like. So this would be analogous to a MetaSound. This right here would be like, here's my MetaSound, and here's my input parameters, right? And this is how you would set up your graph, and then here's how you would play it. So this would be like your Blueprint script driving your thing that you made.
Mhm.
Oh, actually, this would be that. So these are like sort of a scripting thing to drive your instrument. Anyways, it's a really, if you haven't checked it out, you should. And I mentioned C Sound, so I'll bring it up. It's still around. People still doing cool stuff with it. It's one of the oldest sort of audio programming language systems written in C, but you yourself don't write C. It's got a scripting thing. Anyways, I highly recommend this stuff. All right, so now let's talk about MetaSounds, and I want to please interject, Josh, with any questions and anything,
Yeah,
really
actually,
anything.
yeah, actually, our buddy Max Hayes is actually in the chat. Big shout out to
Oh, is
Max.
he gonna correct me? Did I say something wrong, Max?
No, no, he's in there actually answering questions in the chat.
Oh,
So
great,
big
good.
shout out to Max.
I'm not looking at the chat at all. Sorry.
Yeah, yeah, I am. I, I'm giving side eye to the chat. So
Yeah, if anybody has questions that Max isn't answering, let me know. I want to show this too, by the way. So actually, I have a better video on this. Um, so I was talking about extensibility. Uh, is this the one? I loaded up. So, anyways, just this morning on Twitter, uh, Nick Fornell, who I highly recommend as somebody that audio programmers check out. Sorry, I'm trying to. I've got too many windows already open. Um, Nicholas Fernell, who's the maker of GameSynth by Sugi. Let me see if I can get a. I thought I had this open in a. I don't. You guys don't need to see my tweet deck. So he just tweeted out this morning when I was like getting ready for this that he's already kind of plugging stuff into MetaSounds. He's got his whole other like middleware that's phenomenal. It's called GameSynth. He sent me an email. He's like, "Hey Aaron, like I got some programmers who want to dig into MetaSounds," and I just brain dumped him where to get started, which I will do for you guys. Um, and he went and made. He's got all these amazing synth models. He already went and made this amazing, basically like rain model. See if I can full screen. I have it ultra wide, so the full screen doesn't work. But anyways, I recommend checking this tweet out. This is all driven by Blueprint, and he, already is extending and bringing his own pre-existing tools and just plugging them into MetaSounds, which is really exciting to me. So if you are an audio programmer out there listening, and you've got your awesome stuff that you've been doing VST plugins with or building stuff in Juice, which, by the way, if you're new to audio programming, please check out Juice. I know Josh is big into teaching people about Juice. I highly recommend learning Juice, and all of that stuff is useful and applies in games just as much as anywhere else. So anyways, hopefully MetaSounds will be a way for you to get into games and get your stuff into games.
Absolutely.
So I'll do a quick demo of this, and I would like to actually show the code and how some of this works. So I'm gonna we have a whole bunch of documentation on how this stuff works in detail, but I kind of want to just briefly kind of break. I made this MetaSound here as like a demo of synthesis, and I want to quickly show you some of these other MetaSounds that were made by other sound designers at Epic for the Ancient Valley of the Ancients, which is the early access project that shipped, which you can download for free. So this is something you can download and dissect and study. But I want to show you mine. This kind of shows you just a fun music demo, which was inappropriate for Valley of the Ancients. So that's why this isn't shipped. We were thinking about having a thing of just cool demos of MetaSounds that weren't actually used in the project, but if you only knew how production worked in games, we did not have time. All right, so I'll play this again. I played it briefly before. So what this is a little procedural music thing. This is all pure synthesis. There's no sounds that are playing. And this features a couple of cool things right off the bat. So on the left here, you see the input parameters. These are the input parameters that can be driven by gameplay, but also while you're patching, you can update it. So it's similar to like what you might see in Maximus P. So as I play this, for example, the BPM, the beats per minute, can change dynamically. So this BPM is getting read here, input BPM, and driving a thing that turns the BPM into seconds, which drives this trigger repeat. This is a sample accurate. This is really important. I mentioned the sample. This trigger is happening such that in the graph, the output timing is down to the individual sample. What that means is if the graph is rendered at 48,000 samples per second, this has a timing resolution of 1 over 48,000. So that's pretty powerful. And I want to emphasize too that, and I'll show the code here, the audio rendering block for the whole MetaSound, this whole MetaSound is fixed. And so what this is doing, and I'll show you the code of how to do it, it's actually allowing you to basically start rendering audio within a node at an arbitrary point in time. So anyways, and the power of that BPM is useful here because like the BPM is really fast here. It's 193 BPM. It will be perfect timing, no hitch, and it can start going into audio rate BPM. So I'll just demo that. Let me set the beat probability to 100%. You can see right here. So it just is more even. You hear it repeating a melody. So this is 21,000 beats per minute. With perfect timing. Which is kind of fucking hilarious. Sorry, I don't know if I can swear in your stream, but I think it's hilarious.
That's amazing.
So yes, with sample accurate triggering, it opens up a lot of really exciting stuff. Like for example, the sine generator. We have this trigger here for syncing the phase. So what you could do is have another sine tone with a threshold trigger on threshold. So when the sine phase goes above 0.8, output a trigger, and you can at audio rate synchronize this sine tone. So I just want to emphasize that this is crazy that you can do in a graph. Like if you know, so this thing's running at 440 hertz. You know, you can make it 880 hertz. Doesn't matter at the level of sample. At some point, 1/48,000 is not enough. but as long as you're in the realm of your sample rate of your graph, this is gonna do some pretty crazy stuff. So this is a synthesis technique. So it's synced to oscillators. Anyways, there's a lot of stuff that you can do with that. So I want to show. So this counter's coming in. It's counting it every sort of period that I set. It resets the random seed for all the random generators in here, and so that's how you're getting repetition. And it's different every time I play because it's just random. So I have this thing hooked up here to beat probability. All this means is that when a trigger happens, I basically roll the dice here. That's what this guy is, between 0 and 1. And then I do a comparison at sample rate of what the probability of that would be. And then I output a true or false based on if, you know, the random dice is less than this guy. And then if it's true, then I output. So this is a sort of a vent filter. So if I decrease this, you can, in real time, and the choices are repeated, so the rhythm is repeated. In the audience, so he made this he probably thought it was nuts. I was like, Max, we need to encode into MetaSound all the scales. He's like, all this? What do you mean all the scales? I'm like, all the scales. All of them. What? Literally all of the scales. Here's all of the scales. There's more, but this is a lot of them. There's like, you know, it's a lot of the scales that exist, and this is encoded. It's an enumeration, and you can basically feed the enumeration to this. If you disconnect this, you can see the enumeration here, and that'll basically convert into an array of scales, which then are randomly chosen from. So this is how, you know, we do random note picking in a scale. So you don't have to sit and make an array of like, here's all the scales, you know, note choices. We just built it into the thing. And so like this is Dorian. It sounds minor. Let's try it. Change it to major. So let's do major pentatonic. So I have it restricted to chord tones only. This actually will select out from the scales stuff that would make out a chord. So I can uncheck that, and you'll get a. Well, let's... And the length of the melody is also something that we can change. So here's every 4 beats. If you change the beat probability back to 1. So every 4 beats it repeats. You can make it down to... Make it... We could also drive this by an LFO, which I think is a fun demo. So let's do it to like 2 to, let's say 10. And then convert this to a integer, and then this will go to here. And let's make this a little bit slow. And so now we've got an LFO that's going to slowly oscillate on the length of the melody. So if you're into modular synthesis, which I am, if you see behind me, a lot of us on the audio engine team at Epic are into modular synthesis. What I just did is very common. Like you'll have a little LFO and you'll quantize it, and then that'll go to this kind of thinking is like in the world of modular synthesis. Anyways, melody generation, just randomly pick some stuff. I got a little logic for octaves, and you also have a key input. So this is basically offset. So this, for example, can be LFO'd. Let's do between 1 and 12. Make it really, basically when you convert it to an integer, it quantizes the slow oscillation. And then I have to put it back to float. So this will be like a little, very slow chord progression, right? This probably should go a little bit slower. Anyways, you can see, there, you can hear a little bit of the chord. Slowly rising in tension. Anyways, it's funny. And of course, you can change this in real time. So I can, and explode. Anyways, you got that. We have a little debug thing, which is what you're seeing print out over here. I just, labeling what the note choices are. And then here's the synthesis. So this is just a raw sawtooth oscillator. I have it going from MIDI notes to driving frequency, and then I use two oscillators. It's a very common subtractive synthesis technique. And one of the things I have in here is a wave shaper, which kind of gives it a little bit of a crunchiness. And then I'm filtering it. I should have, where is my, over here, I also have a detune parameter. So detune allows you, it's a very powerful subtractive synthesis technique. So there's a lot of sounds you can get with slight detune. You make it a fifth. A fifth is 7 semitones. So now you got the sort of that fifth sound. And you can do fifth with a little bit of detune. That's a very classic synth sound. And then I've got filtering. We've got a bunch of different filters that we've implemented, different types. Sample and hold, by the way, is a fun one. It's like audio rate in. So this could be driven by a noise oscillator. And then at audio rate, you're sampling at every time you trigger, you sample the value of the noise and it just outputs a constant value there. So this is a potentially very useful tool. It's a modular synthesis concept. And then I've got a little envelope generator so I can show you the attack decay time. So I've got this driven. If you slow down the BPMs, you can hear the. Actually, let's do the beat probability. Make that like 0.2, and you should be able to hear the. Whoops. So this is in seconds. The attack time. Then we got panning. You've heard it just go back and forth. It's a really simple LFO on an interaural time delay pan. This is a technique for panning. And then I've got, I have this disconnected, but we got this. I can connect here to here, then there to there, and just drop in a stereo delay for funsies. This is driven by the BPM, so I changed the delay time based off fractions of the BPM, which is a sort of a tempo sync delay. So what's cool with that is as I change it, you'll hear the delay length change. Here's 26,000 BPM down to 67 BPM. one thing to point out too is that the reverb is not in this graph. This is actually happening plugging into our existing pipeline that I was mentioning. So if you click on this general tab, this is the sort of audio settings that any sound in Unreal Engine gets access to. So this is just our whole feature set of our audio engine. So you can see modulation, voice management. This is sort of managing the polyphony if this sound is played multiple times in a level. And one of them is routing your audio through the submix graph, which is what I was telling you earlier about the channel stuff. So I have this hooked up to a demo submix, which has only one submix effect on it, which is this reverb. So you can hear, the MetaSound here is playing through this reverb, and this is all live updatable. So if I give you like an example here. Make the pack decay time. You hear that huge reverb?
Yeah.
Anyways, all of that is, and we have a ton of effects, by the way. So all of that is just plugged right in. All right, so before I go on to actually showing some code, what time we get? So I'll give you kind of a quick rundown of what it looks like in code, but I wanted to show you a couple other demos here of MetaSounds. So this is a ambient music. So this is basically a little procedural ambient music system. I wouldn't say it's fully procedural; it's pre-made pieces of music. So this is a wave player. But the wave player is in the context of all the power that I just mentioned. So we're talking anything that you can do with a modular synthesizer, you can mess with these audio buffers here, right? But in this case, it's sort of a more traditional layered music system in video games. One of the things that this features is sample accurate concatenation. So I want to emphasize, when you do with this wave player, because triggers are sample accurate, when on finished triggers, that happens on the exact sample that the thing finished. So if you were to hook that up to another wave player, it'll automatically sample accurately concatenate. So if you have a wave player and then another one, you can chain your audio files together. But if you want to do a loop, that's like when this sound finishes, as soon as that guy's done, start another sound, like literally concatenate the audio file. There's a technique that we built into this wave player that uses on nearly finished. So this graph is directed acyclical. It's called a DAG. So you actually you're not allowed. This is different than blueprints. If you're familiar with blueprints, you're not allowed to connect anything would create a cycle directly. And so to get around that, it's obviously very powerful to get feedback. To get around that, we have this mechanism in early access called transmission using this send and receive. We're working on some tech to make this better for lots of reasons. Right now, this is global. So the send and receive here will be broadcast to all MetaSounds. So if you're in a level, you can actually trigger, which is crazy. It's a mindfuck. If you think about it deeply, what it means for sound design, you can have one sound broadcast and communicate with every other sound in a game, right? So this actually writes to that's why it's called an address. Think of it as like a register. So this trigger then can trigger all these other sounds in the world. Sample accurately, I want to emphasize. But it's sample accurately, but it is the next callback block render, which is the thing that we're exploiting here. So if I write into this receive will be the next block render. The output trigger will happen. And so that's how you prevent the cycle here, but that's how we also do a sample accurate concatenation. So when this thing is nearly done, it's not actually done, nearly done, we output a trigger, which then is received on the next block, which is when this thing will actually finish. You're like anticipating it being done. So when this actually outputs, it's about this render wave player will finish, which then what we do is we randomly pick another asset to play, stuff it into here, which takes advantage of this guy's feature, which is when it finishes playing a sound, if there's a new sound on the input reference, it'll start playing that one at the exact sample that it finished the previous one. So this is sort of a way to get feedback to sample accurate concatenation. And it works great. So this particular pattern would be an example of something that we would put into a reusable topology, because you can see that he uses something similar in this graph a whole bunch of times. It's like the same topology. So each of these would be like a subgraph, or in a reusable MetaSound. We just didn't have that feature by early access, so he just copied and pasted it. But the idea is that you do this once and then use the pattern forevermore. And this could probably be put into like, you know, uh, concatenative wave player or something. I don't know what you'd call the subpatch, but that's what it would be. So you just give it an array, and when it's done, it concatenates the next one. You'd probably make it so that you could stop it, things like that. But whatever. So that's how this works, and then he's got all these different layers going together, and then going to a mixer node. This internally just mixes all the different audio, and he's got some input parameters that he can drive from gameplay. So the bow, like all of this is something that a Blueprint script could drive. So like, oh, I want to pull up the woodwind, I want to bring down the bowed stuff, and so it can be totally gameplay driven, and then it just outputs the audio. So you listen to it, it's a really, beautiful pitch. He actually is pitching things down octaves, which is cool. So what's interesting from a topology analysis, he has two pieces of music he wrote. One for the dark world, if you play the demo, and then one for when you're in the desert before the dark world. And the graphs are identical. Like if you look at them, they're pretty much the same, and with just there might be a couple divergent differences, but the only differences are which audio file inputs are there, and otherwise it's pretty much the same behavior. So this would be a perfect example of a reusable MetaSound. We'll use this probably when we actually get presets and be like, okay, can we reproduce this, music with a preset? It's very different music. So I wanted to show you also a kind of like bread and butter type of thing. Again, think of this in reusable parts. So this is the same graph 3 times. So this would be a subgraph. This is basically just a procedural flapping thing. Simple. But what's cool is that these are the variances. So small, medium, large. And this would be something that could be driven outside of this MetaSound as a preset. So now you've built a topology that is kind of like a little looping, flapping thing, which could be used for all kinds of different audio applications. And then this is our showcase sound that we showcase in the UE5 preview. This is a combination of synthesis and sound files. So you see here saw generators. This is something you can dig in. It's got filters, envelope modulation. Here's the sound waves that sort of bookend. So it's like the shot and then the finish are sound waves, that kind of a thing. So it's a really good demo.
There are some people that want this patch or want your patches. Is there?
Well, this patch is in the early access demo.
Oh, okay.
So all of these are in the early access demo. This one is not. This one I just made for this.
Got it.
So this one is not. But I don't know if there's an easy way right now to distribute this. I'll ask my team, but maybe I can post this somewhere. Like just drop it in your audio programmer.
Yeah, we could drop it in the Discord, and we can also drop it in the video description afterwards.
As I mentioned, this stuff is representable in JSON. I don't know if it's in a way that we can copy paste JSON yet, but theoretically, and it would be kind of a fun thing to try out. Be like, hey, people really want this patch. Let's try to solve this, so I can just like copy and paste and be like, here's the JSON file, and then paste the JSON file into here, and then boom, you've got it. Because if you have all of these nodes, which you will in early access, you should just be able to paste it in.
Yeah.
This is all represented in a document model.
Kind of like the Max MSP.
Yes, exactly. It's exactly like that. Yep. So let's talk about the code briefly. I don't know how much time we have. Do we have time?
As much time as you'd like. Yeah, seems like people are really excited about this. And
all right, we still have an audience. Did everybody leave us?
No, a few people still watching. Yeah, still watching.
All right, so this is what the C++ code looks like. I want to show you, if I open the containing folder, if you sync up, you'll have, we've got a lot of nodes. It's in the runtime MetaSound. So notice, plugins, as I mentioned, it's in a plugin. So all of this stuff is in a plugin. MetaSound, source. You can, if you want to know our front end, here it is. This is how we do, all of it's there. So if you want to figure it out and find our bugs and help us fix them, that's great. So these are all the nodes that we shipped in the standard node library. So there's like a name spacing thing. So if you're building your own plugin, you'll probably come up with your own library name for your plugins. We haven't fully worked out the entire cleanest path for another plugin to start adding stuff, but it is absolutely supported. There's a thing called the MetaSound node registry. When the thing loads, your plugin would just register your nodes that you've implemented, and then that would show up for the MetaSound editor as stuff that's optional. But the whole like way we think about the ecosystem is still kind of a work in progress, but it's architecturally there. It would be fun if anybody out there wanted to blaze the trail. It looks like Nicholas Fernell's doing that kind of stuff. So
Yeah.
if you're watching, Nicholas, I would love to hear your experience of driving these in a third-party plugin.
Um,
So, anyways,
is there a way to increase the font size?
oh,
No,
I have a. How's that? No,
yeah.
not really. Doesn't help.
All
I
right.
can do it over in Visual Studio. Anyways, point is there's a lot of nodes, and that's where it is. So this I can increase. So
Hmm.
all right, so I picked out a couple MetaSounds. I wanted to first, before I get into MetaSounds, I want to show you that this is built off of the Soundwave Procedural, and I built this synth component tone generator for pedagogy reasons. Like I built this so people, it's like intentionally the simplest possible way to get synthesis in UE. So I would point your audience to check this out. It's in another plugin, but it's in the synthesis plugin, and what this is what's called a synth component. And all of MetaSounds is actually, it's not a synth component, but all of MetaSounds uses a sound generator. So this iSound generator is MetaSounds. In fact, you could say MetaSound sound generator right here. So you can see that MetaSound implements iSound generator. So from a C++ architectural standpoint, this is complicated, hard to dive in right away. This is the sort of hello world of an iSound generator. So I recommend, if you want to get into how MetaSounds work, start with this. Look at this guy. This is the hello world of implementing an iSound generator. MetaSounds is the world's most complicated iSound generator. But that's what, you build an interface and you're like, okay, what are the simplest things that we need to implement? And it's very dead simple. It's like on generate audio. On end generate. This is optional. Like, so you get a message when we're done generating. Get the desired samples to render per callback. And here's where the architecture I was talking about, MetaSounds can render arbitrary callback blocks because it's built off of this already existing architecture of sound generators, which have already been architected to have individual block callback sizes. And then, somebody I noticed on a forum I've meaning to ask, you have to really think about threads. So synth command is a way for you to, it's like a utility that is in iSound generators that allow you to put an arbitrary lambda function that will then execute thread safely on the audio render callback. It's not the audio render thread, it's the task that onGenerated audio is called on, which is why it has to have its own command queue. It's not a shared global command queue. Each generator has its own command queue, which is if you're. But anyways, so I recommend this is a sort of entry point to iSound generators. That's sort of if you want to go deep into the MetaSound architecture. If you just want to write a node and call it a day, here's a good one to start with. MetaSound MIDI to Freak node. So I want to emphasize something that's really cool. To add a new node in MetaSounds, you just need one audio file. This one audio file, not audio file, sorry, CPP file, you drop this in. If you just want to get started right away, get the source code, build the MetaSound plugin, and then just add your shit straight to here, and it'll just show up. If you want to start redistributing your stuff, you'll want to, and not get stomped, you'll want to build your own plugin. But if you just want to start experimenting, just drop your nodes in here, and it'll just work. And like when I make a new node, I'll pick one that's kind of close. I literally copy and paste it, rename it, and start having fun. So I recommend that as a way to just get started in exploring and just figuring things out. So if you just play with MetaSounds and go like back to here, you're just like, oh, I want to do something like I have an idea for an LFO. I want to do something different. So maybe you'll study this one. This one's a complicated one, but you'll learn stuff. Or you're like, I've got a better idea for an envelope generator. I want to do segmented enveloping, which is something I wanted to do. I just didn't get to for early access. So grab the AD envelope, crack it open. It's right here. See how I did this, wrote this code. Find my bugs, fix them, send a pull request. and make your own generator, you know. So, but anyways, I want to break this down. We don't yet have documentation on the C++ side of this stuff because it's potentially going to change dramatically. So I should preface all of this with we do have plans on changing this a little bit because it's I would say a little bit it's a little boilerplatey right now, and we have some ideas on reducing the amount of boilerplate that you have to implement. But you know, it's still worth checking out and learning. Just know that your stuff might break by 5.0, but it's a learning process. Don't give up. Anyways, this is a good one to show you. Essentially, if you MIDI this to show you what this node is briefly, I'm using it in that graph that I showed you. It's the MIDI. This is the MIDI to frequency node. Where is it? It uses where is it? Over here. It's this guy, MIDI to frequency. It's really simple. It takes a MIDI value input, outputs a frequency in hertz. So this is why it's a really good node. It's really simple, two things. And if you hover over here, it says a value representing a MIDI note value. Could probably reword that. It should be a value representing a MIDI note, period. Why do I need to say value twice? But whatever. Output frequency value in hertz that corresponds to the input MIDI note value. The word value is used too much in these tooltips. Anyways, and I have two of them, MIDI, which is why this makes a good one. So we have MIDI to frequency int32, which takes MIDI int input and float input. I decided because MIDI is often thought of in terms of discrete, because, and I want to emphasize this is not actually MIDI. This is the MIDI note value. This is sort of using the MIDI standard of notes so that you can conceptualize like middle C is 60 and not have to have enumerations everywhere. You just do mathematical operations, and then this converts that standard into frequency in hertz so that you can drive oscillators. That's all this is doing. So so this is how you set up your input and output parameters from a tooltip perspective and definition perspective. So this is a macro that I wrote to make it a little bit easy to define some of the boilerplate from our experience. It's kind of easy to make mistakes. So let's skip through this. If you're into C++ and template programming, this is how you do like a template specialization. This might be a little bit overkill. There's like at least 10 ways to skin a cat in C++. This basically a MetaSound node is broken into two primary objects. One is called an operator. This is the thing that is actually instanced and gets generated. The execute function here is called whenever a block of audio is either rendered or processed. So you'll see this execute function. And then the other node that you want to implement is down here called the actual node. And then the final step is registering that node. And so this is how the CPP file will indicate to the rest of the MetaSound front end that your node exists. And this is just a macro that implements a bunch of stuff that would be painful to write. But it basically just does a bunch of stuff and queues the initialization commands. When the thing loads up, it'll go through all of the queued up registration stuff, so you don't have to worry about a lot of the complexities. And so in this case, I built the node. I templatized the type, so it's int32 or float, and that's what you see down here. If I wanted to make a MIDI to freak node string, I could, but that would make no sense. I guess maybe if you wanted to have the string value of C, that's actually not a bad idea. So I could type in like C flat, or not C flat, B flat, and have that be a MIDI note. That's not a bad idea. And there's some boilerplate here. It would be really boring to go through it, but the key thing is this basically this idea of MetaSounds are made up with these ideas of vertices and defining vertices. Without going into extreme detail, I'll just talk about one concept, which may be something that will cause you confusion, is input pins are constant read-only refs. So input pins are represented by a read reference. So this T data read reference type, this would be like T data read reference int32, T data read reference float. So data is not inherently copied between nodes. This is a sort of conceptual hurdle that might be confusing. So data is referenced. Whenever you make a connection to one pin to another, it's a reference to that value, which is how we can have one output go to many different nodes. This is not copying to here, to here, to here, etc. These are all just referencing the one value that's output from this plus, right? Same thing with over here. This audio buffer and this audio buffer are referenced as the input pins here. Audio buffers are not getting copied around. So theoretically, if you had a graph with, saw audio buffer just going through a bunch of filters, they could all be processing in place, and you just, even through the whole graph, it might just be one audio buffer. Now, buffers do get copied, but it's up to the node whether or not it copies. It's not an inherent like property of the graph itself, if that makes sense. So like this plus is a reference to this guy, a reference to this guy, and then they add it together, outputting a new buffer. So this buffer has not ruined these, so this could actually go and do something else. I could, which is crazy, but really powerful. Like you could do something like this. So
Wow.
this sawtooth is getting added to this sawtooth, adding it out. This then references the original thing that's referenced here. It's the same reference is now multiplying it by here. I mean, you can just this alone is a really powerful DSP thing, right? Like this is ring modulation. You're like ring modulating the sawtooth with the other sawtooth back off itself, you know. But the important thing is that it's not getting copied. And then the output is a write ref. And so those two concepts are important. So this would be a float write ref. And then internally you can have as many, internal, you could include your whole DSP object if you want. And then a lot of this boilerplate is basically just making sure the graph knows the inputs and the outputs and what their values are and what their types are. You can do clamping, you can do all kinds of stuff, what you'd expect. And that's in a nutshell what it is. It's all the boilerplate is just hooking up those vertices correctly. And I recommend using this helper. This is what do I call it? MetaSound param helper. Just because all the places that you need a boilerplate, it's easy to do a typo, and MetaSounds will kind of break in a way that's annoying. This is part of the thing that we want to make it a little bit more smooth, but just use MetaSound get param names to make sure that you don't accidentally typo the param name so that everything is properly hooked up. But anyways, this should give you an idea of sort of where to start. I want to show you one more node in depth, maybe two more nodes. Before I go into the AD envelope, let's talk about the delay node. So this is audio buffer in, audio buffer out. So the delay node is right here. This is this. It's just one audio buffer in and one audio buffer out with some input parameters. So you can see in, delay time, dry level, wet level, feedback, and out. That shows up here automatically. And it's nice because it's an example of like a DSP operation. It's pretty straightforward. So in the callback block, so we're not going to go through the boilerplate. This is what the callback block is. This is your audio render loop. What you do is you get your updated parameters. So this gets your delay time. This basically clamps, gets the delay time. This is the input parameter for delay time. I get it in seconds. I clamp it between what I decide is my max delay because, for a delay line, you've got to allocate a buffer of audio ahead of time. That's like show your max delay. And this is in seconds. I change it to milliseconds because this DSP object that I have internally, this is something that's implemented already for us in right here, audio F delay. We have, by the way, I should also plug our DSP library. So DSP delay. So let me go to that, and I'll show you. So we've got, this is we've used this in a million things. If I go to the folder here, you can see our existing growing DSP library. So if you're learning audio programming, this is a great place to learn both how to and how not to do DSP. But like Bit Crusher, if you're curious how Bit Crusher works, here you go. There's the Bit Crusher. Like, see how we did it.
Wow.
Yeah, it's a whole library. There you go. Phase plus delay, quantize, build. It's all there. It's like a treasure trove of DSP shit if you're really into it. Flanger. This was actually just checked in by Helen, one of our new interns. LFO. Actually, I don't know if she checked. The file was there as a stub, but she actually implemented ring modulation. If you want to see that, we have multiple reverb algorithms. Reverb fast. If you want to see an awesome reverb, this is a plate reverb. If you want to see how one would write a plate reverb, that's the reverb that we're working on. Reverb is a fun topic. So anyways, going back to that, a lot of our nodes just wrap our existing DSP API. All right, so delay node. So this thing is the thing that we already wrote. So we set the delay time. We get the input audio. This is the audio input reference, that pink thing that was coming in. And then here's the output. Notice this is const, by the way. So it's a const read-only reference. So we cannot write into this. That would break the MetaSound graph contract. And then this is the thing that I can write into. And then I just clamp things. So MetaSounds, the world of MetaSounds is a wild and crazy place. So any input parameters, you should clamp them to make sure crazy shit's not happening.
Pulling your ears out. Yeah.
Yeah, exactly. Who knows what someone's feeding your inputs, right? They could be some insane, like, who knows? And then basically we just feed it and process it. It's a really simple little delay line processor. Just feed the wet level, dry level. With this one has feedback. One thing to do sometimes is the thing in DSP code. Maybe it's over optimization, but you kind of want to try to avoid doing math if you can. So it's worth maybe branching even if the code gets complicated. If someone has no feedback, don't even do this math here. Like this, multiplying a bunch of zeros and stuff might not be great. It's best to profile AB before you do stuff like this, but sometimes it's easy to just do it, and it's probably not going to be a huge deal to branch once and then avoid doing a bunch of math. I recommend not branching within a DSP block if you can avoid it. Sometimes you can't. And then finally, this is the most complicated example of the three because it deals with the sample accurate triggering. And I wanted to show this to you how that works. Because the sample accurate triggering is a new approach to audio rendering in the world of C++ programming for audio. So let's see if the best place to... this is basically all of this stuff is just sort of the envelope state. Am I in the attack phase? Am I in the decay phase? Am I looping? This AD envelope supports looping, by the way, which is a really cool feature for envelopes. So I'm going to show you the AD envelope. So if you are familiar with modular synthesis, this is intentionally modeled somewhat loosely off of the maths module, which is by Make Noise, my favorite modular synth company. Maths is like basically two of these. And so one of the cool things is being able to loop an envelope. So you could have this be like a really awesome LFO, essentially. It just will infinitely loop. And you can change the curve here. So this would be like, I would like to have a graph in these things, by the way, to make it more clear. But this would be like, if it was a pitch, it might be oop, or rather than like boop kind of a thing, it would be like boop or boo kind of a thing. You can make it go fast or you can make it kind of sharp. So that's what this is doing. It's just doing the math on that. But anyways, that's what this idea of the looping is. If you go back, you gotta, like, if we're looping, reset the sample index. You go back to the beginning of the envelope. So this is a really good thing to kind of show how you do envelope state machines. But the important thing here that I want to highlight is the trigger. Where the hell is the trigger? Right down here. So execute. So this is the newness. All right, so trigger attack in. So this is a read reference. A trigger, if I alt-G'ing to this guy. So this is a trigger read reference. So what this is doing is so we got the execute block for the whole MetaSound render block, right? And what I'm saying is trigger, if you are getting triggered, this is what I want you to do. See, what's the best way to say it? Basically, the trigger itself allows you to render audio in sub blocks. So the whole render block might be 1024 frames, but trigger allows you to say, actually, here's a little bit of audio, here's a little bit of audio, here's a little bit of audio, and sort of break up that render block arbitrarily. And that's how you get sample accurate triggering. And so that's the sort of high level idea of what this is doing. Concretely, how that is implemented to help you as a designer is you give it two lambdas. So these are two lambdas. If you're not familiar with lambdas, check it out, C++11. And this lambda is handed to it to, this is what I want you to do in your callback before a trigger has been triggered in your callback block. So if no trigger has been rendered, this is actually the start frame and end frame are the size of your audio render block, right? But if, like, say, 70% through your audio render block, you get a trigger event, this is the lambda to execute from that trigger point to the end of the render block. Does that make sense, Josh?
Yep.
So the
Yep.
start frame would be like where that trigger happened, and the end frame would be the end of the render block. And then the other case is if you're getting really freaking fast triggers, like that case where I showed you before, where it was like 20,000, beats per second. What would happen is the start frame and the end frame would be still sub block. So if your 1024 render block might have start times and end frames that are like 80 to 85, 85 to 90, 90 to 95, 95 to 100. So it'll arbitrarily bifurcate or split up your render block from the start frame to end frame. These are the input parameters on the lambda. And so your logic then can be arbitrarily precise and complicated to handle all the kind of cases that might happen for a sample accurate trigger. So in this case, the on trigger is like when I want the envelope to start, so it handles the sort of start logic on the state machine, right? And then the on pre is like we've already been started, so just get the next block, right? And so get next envelope out is sort of the share up reusable logic here between the beginning, where this guy just knows its state, and if it hasn't been triggered yet, it outputs 0, basically, right? And if it has been triggered, it knows what state it's in. It's like, oh, I'm in the attack phase, I'm in the release phase, and this just does what it needs to do based on the state of the thing. And then here, this is an interesting use case to highlight because triggers are sample accurate, and because envelopes, I have this unfinished envelope trigger. It's possible for multiple end finished triggers on trigger finish to happen within one render block. This guy right here, on done. If I'm set to looping, on done can trigger many times within one render block, right? And so the way I handle that is I create a list of the number of frames that got finished in this block. And it needs to be done both on the trigger and on the execute, or on the sort of pre-trigger. So if it's a looping trigger, it's like going to go like and that can go all the way down to audio rate, and it may have finished like 20 times in the callback block. And what I do is I trigger each of those 20 frames. I queue up. This on done is a write reference. So when I say trigger frame, that's writing into this write ref trigger that these are the frames that a trigger happened. So then over here on done, somebody does something else on that trigger, he can then unwrap it to all of those frames. Do you get what I'm saying? So that's how the sample accurate triggering mechanism kind of works. It definitely adds some complexity to node construction, but the benefit is enormous. Now the downsides to this, there's a couple downsides. One is obviously it could potentially hit performance as you get crazy high trigger rates. The whole point of rendering audio in a block is that it's an optimization. You can't render things per sample. But the nice thing is that this is not feeding audio to the hardware per sample. So the performance hit isn't the same as if you were to say, like, let's make our callback block one frame, or whatever. That would go like, it would stutter like crazy. So it's not equivalent to that. You're still rendering the audio in chunks of audio, just like you do traditionally. It's just you're sort of logically allowing you to subdivide that arbitrarily per node at any point. The other complexity is if you have a node with multiple triggers coming into them, how do you deal with the order of operations on that? And the answer right now is it's a little bit of an R&D thing, but there's if you look at trigger accumulate, for example, let's do a better one. So trigger accumulate, this is entirely built on receiving multiple trigger inputs. So what this is trying to do is when all 5 trigger here hit, it'll finally output 1 trigger. So the purpose of this is like if you have a whole bunch of different, there's a lot of purposes with it, but you have a bunch of different wave players, not wave shaper, wave player, and they're all playing at the same time, and you're mixing the audio together. Each of them will have an unfinished, and you want to finish the whole MetaSound. Where's the unfinished here? When all of them have finished. That's sort of the basic idea.
Mm-hmm.
So because of that I kind of glossed this. I didn't even mention this. MetaSounds are totally procedural, so you have to tell the MetaSound when you're done, otherwise to make a one shot, in game terminology. So anyways, if you want to play a whole bunch of different sounds and they're all layered together, you got to wait for all of them to finish, and this is how you do that right now. And I want to emphasize topology. This you might, if you're an audio person, game audio person, you might go, "Oh, I gotta do this for every time I make a sound." No, no, no. You do it once and reuse it. So this might be painful, but you're not expected to do this every time you need a sound design, right? You would build a topology that's like, oh, I got a sound topology that I want to layer five sounds together, and then I want to finish the sound when it's done. And then you drive what sounds you play and you reuse it as much as possible. So you know what I mean from a workflow perspective. Anyways, so it gets complicated dealing with multiple triggers in one block and how do I sequence those things and things like that. But that's the other downside. I think that's it. That's all I wanted to show. So I guess we can do Q&A. It's freaking noon, so this has gone longer than I expected, but that's fine.
Wow, this is really cool. So, so I guess the quick summary feels like it's kind of like Max MSP, but you can write your own nodes and your own objects.
So Maximus P has an API to do that as well. Have you checked it out?
Well, I know that you can write externals and things like that.
Yeah, that's what they would call it.
Yeah.
I
So,
mean, I actually have done a whole bunch. It's cool. I feel like our API is a little bit easier to expand on than theirs. Theirs is pretty. It's not bad, but it's a little complicated.
well, it's C, right? It's not C.
Yeah.
Not C.
There are people who have done C++ wrappers.
Hmm.
A really good friend of mine, Graham Wakefield, did a C++ wrapper of the C++ Max external Graham Wakefield. So I can just find it. This is the. I'll share my screen again. Graham, by the way, is one of my best friends. He's amazing. So this is his GitHub. Maximus P, C++ templates for Maximus P. So if you want to write Max externals, this is what I would absolutely check this out. It's phenomenal. So he has made it much easier to write Max externals.
Wow.
So I highly recommend it. So you can do this in Max, but and look, I mean, it's not that hard to do this. I actually like one of the other things I recommend. You said recommend for new people. Learn as much as you can. You get overwhelmed. You kind of get paralyzed by doing too much. So don't try to learn everything at once, but be open to learning new things, right? And go deep on stuff, but don't stay on one thing forever. You gotta keep feeding yourself new ideas.
Balance.
It's like it's a balance. It's absolutely a balance. But
Balance.
some people learn one thing and then that's it, but then you limit your mind and what you can do.
Hmm. Yeah, balance in just about any aspect of life is
Exactly.
yeah. Uh, yeah, so that's really cool. That is awesome. So I guess one question is just in terms of is it going to stay focused on game development, or have you had any thoughts about like wrapping this up into ways that you can get it outside of games? Have you ever thought about that?
That's a great question. So we are working on something. I mentioned the other night to some peeps. We're not trying to be secret. I don't know if you've checked in it. So if you have GitHub, you can follow us along through the next year on all of our development. UE5 main is just open. It's public. So just check it out. You have to sign a EULA to get access to the source. That's the only thing, but you can get all of it. And so in other words, it's technically not open source. You have to sign a EULA, but you can check it out. We are working on something that we're calling Audio Link, is what the working name is, and the idea is to make it easy to both receive audio from sources and send audio out, including hopefully DAWs, like a VST host. You could imagine having a VST plugin. Like I said, we're Juice people. It'd be cool to make a Juice wrapper that basically is an audio link to a Juice plugin, and then you could write a VST plugin that just has audio streaming to it from Unreal Live and back. So I think that would be it's doable. It's totally doable, and it would be freaking awesome. So we are absolutely thinking about ways of bridging the gaps between different domains. There's a tool in animation called LiveLink that animators use for like updating stuff in Unreal Engine with Maya modeling, so that the animators will make their stuff, hook up their rigs, and then while they're doing that in this application, seeing it rendered in real time in the engine. And when I saw that demo, I was like, "Ah, we gotta do that for audio." So like so that's what we're calling it, audio link. And so you'd be like, audio link to your DAW would be freaking sick. Or Max MSP, like I'm a huge Max fan, so it'd be cool to make a Max external that's an audio link to Unreal. So right now people are doing that anyways with like open sound control and stuff like that, but it'd be cool to actually have the audio broadcast over, not just control data.
That's cool.
Yeah.
Wow. Wow, that's incredible. Um,
So
yeah,
yes, that's the
yeah,
answer.
mind blowing. Yeah, there are just so many ways I can see that this would this could be really really cool. Uh, let's see, what other questions?
I agree.
Yeah, yeah. Uh, my mind's kind of blown. My mind. Um, let me think. Let me think. What about like MIDI input, things like that?
Yeah.
Yeah.
So the plans for the MetaSound world, MIDI could be directly input into the graph. It's probably less useful to do that. We have a MIDI plugin already in UE, Unreal Engine, for MIDI input and MIDI output. We don't yet support importing a MIDI file. People, by the way, the world of MIDI is so complicated and ancient. Like, what the hell do you mean when you say MIDI, right? So there's MIDI files, there's MIDI general MIDI. Like, what the hell does that mean? MIDI input, MIDI output, all this stuff. So we already support MIDI input and MIDI output through Blueprint. So already today you could go and make a MetaSound and drive it with your like MIDI keyboard or your knobs and shit like that. There's a team at Epic I just found out about that's doing some cool stuff with MIDI mapping in the editor. And they're doing it in a cool way so that you could do like open sound control mapping in the editor, MIDI mapping. And I always forget the name of it. There's a lighting protocol for communication with lighting. They're gonna do that kind of thing. And there's it's basically a team working with artists and installation artists and stuff. And so a lot of that stuff might just come for free. So like my team won't have to do it. Just be like, oh cool, now you can MIDI map your shit. Because like artists want to have knobs that control their shaders just like audio people do, right? So
What about like do you have anything for timing? Arpeggiator, step sequencer,
in MetaSounds,
yeah.
so the demo I showed you kind of shows that we have arrays, and if you have arrays and the ability to read from the array, you can feed that to your MetaSound arbitrarily. You should go on Twitter and search for hashtag MetaSound, and look, people are making crazy shit, like full on pieces of music. Like, check out Seth Whedon. Seth Whedon's a technical sound designer at Epic, and he was super busy with Fortnite, so he didn't do anything with MetaSounds, and I kept pinging him like, guys, come over here and give us some feedback, and he was like, I can't, I'm too busy, and then MetaSound ships, and he like the first time I saw him use a MetaSound was when he tweeted out his MetaSound. I think it has like 200 likes or something, and it blew my mind. I was like, holy shit, I didn't know you could do that. It's so freaking good. I gotta find it. I should have had it ready for y'all, but um, Seth Whedon MetaSounds. Let's see if I can find it right here. I'll share my screen so you can see it. Um, but like, here we go. So this is Seth's MetaSound. He's like diving into MetaSounds this weekend. It's like, why didn't you do it before we released? I would have left your freaking feedback.
Yeah.
So the problem, I can't. Stupid Twitter. If I go full screen, it goes to my ultra wide, so you can't see it. But I'll just play it for you. So he's got all. This is all pure synthesis. I just want to emphasize. So all the bass drum, everything is all in one graph. Did I mute it? I didn't accidentally mute it. Here we go. So he's controlling it in real time. So you want to answer like, can you do sequencing and stuff like that? Yes. So I highly recommend checking this out. So
Before you move on,
yeah,
I thought it'd be good for you to highlight a comment that you made a little bit below there.
sure. Where did I make something here?
About dolls.
Oh,
Yeah. So some people must be thinking about trying to use, looking at this as like a doll or like
yeah.
a
I'm
doll.
glad you brought this up.
Yeah. What do you think about that?
So It's interesting. I've been like kind of on random forums. I'm like ghosting, like or lurking, I should say, not ghosting, but lurking on random things, and I see a lot of people going like either way, like, oh man, I can get rid of my DAW, or this is never going to replace my DAW. Like it's like, oh god, this is totally not intended to do anything. Use your DAW, dude. Like, and I have a little, a soapbox here on Twitter. I have a little thread here, but the way to think about what MetaSounds is, the best, because like I said, it's like an audio shader. Graphics people still use stuff outside of the engine. They still, there's texture artists. There's still people making textures, still making models. There's people still using outside tools, and then thinking in those domains, doing the things that those things do really well. Like Unreal Engine will never be a Photoshop, and it would be crazy to try to compete with Photoshop. There's like decades of amazing tooling by some of the best programmers in the world, focusing on building this amazing tool set for making images, right? Unreal Engine is about real-time rendering for graphics, right? And so the whole idea is you get your assets and then it's about procedural real-time rendering. So MetaSounds is the analog for audio. Like your whole digital audio workstation, what it does, and it will do so good, and we will never compete, is building sounds and sound design in a different context. Like you can devote 98% of your CPU resources. You could have a PC that's got 200 gigs of RAM and 190 of them are loading sample libraries, right? You would never be able to do that in a game or even in Unreal Engine. So like DAWs do their job and it's awesome. What we're trying to do is bridge the gap. So like communicate between. That's what the audio link's about. It's not. So it's like, oh, all the power, now you can hear those results rendered real time in the engine. Why is that useful? Because audio engines are real time rendered. That has an impact on the audio that you're sound designing in fundamental and hard to characterize ways. When you mix audio together, you introduce constructive and destructive interference. Noise floors accumulate. So a lot of sound designers who don't think about the details of digital signal processing express frustration. They're like, I made this amazing sound in my DAW and I get it in my game engine. It sounds like shit. Must be the game engine. And it's like, no, that's just how audio works. Like constructive and destructive interference is a real thing. Dynamic range is a real thing. So if you've made an amazing sounding asset on its own with a limited dynamic range because you threw it through like several L1 compression, and it's like, yes, it's like the biggest sound ever, and you're like, fuck yeah, this is the greatest sound. Get in your game engine and it's like, can hardly hear it. That was my experience as a sound designer in Dead Space. I remember when I was there, because Dead Space, by the way, was like a loudness war within all the sound designers. If you go back and listen to Dead Space, it is so loud. And I remember by loud I mean dynamic range was very limited. So I remember when I was first a sound designer, the audio director Don Vecca walked into my room, saw my DAW like waveform that was exported, and he goes, "It's not loud enough," and walked away. He didn't listen to it. He literally didn't listen to it. He's like, "It's not loud enough." I was like, "What the fuck are you talking about?" And he goes, "I can still see some black in your waveform." He's like, "Gotta be a sausage," and then he walked out. And I put it through L1, and he came back and he goes, "Do it again." And I put it through it again. He's like, "Do it again." So it was like multiple passes through the compressor, and it was like it's like destroyed, in my opinion, the sound. But then he was totally right. You wouldn't have ever been able to hear it in the game. So that's why older games are really loud. I think sound design has progressed past that point where we appreciate dynamic range for games more than we did in the past. But that's what I'm talking about. Like games are really complicated, and it's really useful to hear your asset while you're designing it in the context that you expect to play it. I feel like that would be a really powerful tool.
Absolutely.
But anyways, DAWs are not at all what we're trying to replace. They're different. They're trying to solve different problems.
Yeah, exactly. And it seems like audio a game audio engine is more event driven, whereas DAWs are more timeline driven by.
Not necessarily. Timeline can be really important in games as well. So I wouldn't even characterize it that. It's really at the lowest, most basic level is game audio is about procedural audio, period. Even simple, pick a random variation. Like your DAW, some plugins are game-like in that you can sort of like randomize stuff. There's some really cool stuff, but overall the idea is that like I've made my sound and I click render export, and then I've got an asset product, right? And it's static. Games are all about dynamic procedural audio. Players are playing them and it's different every time, fundamentally, which complicates a lot of shit. Mixing is complicated, everything gets complicated. And just like in graphics, right? Like Pixar can do shit that's like a billion times better than you can do in graphics and real time. And it's not just a performance thing. People often think, oh, it's performance. It's like, no, no, no. It's performance is important because you have to worry about performance. But the real problem is the interaction and the procedural nature of it for graphics and for audio. Like performance is always a really big problem, so I don't want to underplay that. But and that gives you like an idea of like we're really constrained in terms of performance. I mentioned it already before. Your DAW sound designer can use 90% of their CPU having like 20 reverbs and shit. You know, that would never fly in a game. Same thing with graphics, but removing that, it's still complicated because of the extra complexity, the interaction, the data. Things have to be data driven, so you have to have an army of like really technical people trying to figure out ways of mapping all that data around. So they're different use cases.
One of the things that I've heard as a non-game audio developer is that game audio has been known to take a low priority in the food chain of development. Do you feel that that's changing, or that audio is starting to take a higher priority in game development with spatial?
I just looked at my time. I'm like, how much time do I have? You're basically what you just did is like I've already been on a soapbox, but you just got a bigger soapbox and you said, "Please, sir, will you like to get higher up on your soapbox?" So I'm like, all right, should I get a microphone? How much louder can I talk here? Okay, so uh, audio. This is the underlying thing for me in my career in games is trying to communicate that audio is a extremely valuable and important discipline in media. Period. Not just games, but anything. For film, if you look at the history of film, audio was often also the sort of secondary consideration for all these other things. But I would like to think that film has at least, if I still think sound designers and composers are often treated like shit still in film, but there is at least a fundamental respect for sound in film that exists both in filmmakers. Like, if you're a serious filmmaker, you take audio seriously, period. There's no doubt that if you are a serious filmmaker, audio is important, and nobody has to convince you of that fact. Like, but that used to be the case in the olden days in film, right? But people in power making films, directors, financiers, everybody respect audio, and the audience respects audio in film. So these are the two sides of things. So audience people respect film. You go to a theater and it's like a crazy surround sound experience, all this kind of stuff. So games lag that. Although games are a newer medium, you could probably build a parallel between early days of film and early days of games, where it's like the sad Foley artist is getting disrespected in like the 30s and 40s or whatever. Hey, wait for me to do my Foley. Like you got tomorrow to finish. Games have the same kind of thing. We're not quite at the point where it's a given that if you are serious about games, that you also are serious about audio. Although that is changing. I would say in AAA it's still there. There's like a respect for audio. But there is still subtle things that indicate that we're not quite there yet. See if I can. I have lots of examples, but let me see if I can. So if you look at just straight up budget, like how many artists it takes to do something versus how many sound designers does it take to do it, it's almost always stratospherically more visual artists are hired and employed than sound designers. It's like you expect, for example, in graphics, you might say we have an environment artist, we have a lighter, got like a team of lighters, we got a team of environmental artists, we got a team of texture artists, we got a team of technical artists, of particle VFX artists. We've got a team of animators. We might even have a character animator. I mean, hell, you might even have somebody who specializes in hard materials and another artist who specializes in soft materials. Like the specialization in visuals and graphics is so unbelievable. And then you look at the audio side and you have a team of, if you're when I started at Epic 6 years ago, there were 3 audio people, and 2 of them were audio directors, right? And this is a company that shipped Gears of War, so they'd already made AAA quality, and their audio team was still 3 people. Now they have a much bigger team, and they're cooking with gas, but still, it's in my opinion, still, and they would agree, under under resourced relative to both of the expectation and scope of the content that they're trying to produce on Fortnite, and also relative to other teams, right? And it's like 100 artists making skins and stuff for Fortnite. So you expect one audio person to be all of those things that exist in graphics. Like one audio artist is doing the Foley, doing the environment art, doing all this stuff. A texture artist might be the sound designer going and getting that sound file source material, going out into the world, sampling the reality just like texture artists do. A texture artist will go out in the world and find really cool textures, right? Just like you might have somebody in audio also expected to go out and capture source material in the real world. A Foley artist is similar to like a texture artist trying to make cool textures and taking pictures of that. And so there's one-to-one analogs, but audio is expected to do all of it with shoestring budgets, with no time after the fact. Production is always still going, like, thinking about when art is under lockdown, and then audio. So anyways, it's a nightmare. It is improving, and it feels sometimes like it's not, but if you look back in time, it is improving, sometimes too slowly. All right, so that's my feeling about audio as a discipline. Now, in terms of programming, I don't want to say anything too controversial, but I will say that I feel like the more audio engines, the better. The more different people who are employed as audio programmers trying to push the envelope in a fundamental way, the better the industry will get. And that's true for graphics, right? There's a shit ton of graphics programmers who build graphics engines and are really into pushing the boundary of what it means to be graphics. Nanite and Lumen are perfect examples in UE5 where, holy shit, I didn't know you could do, I forget the term. I'm not a graphics person, but whatever Lumen's doing, it's really cool. No one could do that before, and it's like a cutting edge technique. Same thing with Nanite, right? Those are things that wouldn't happen if we were all sitting in graphics with a shared graphics engine that everybody uses and nobody really extends, and we all just sat there going, this is how graphics are done, and we never tried to push the envelope, never tried to reinvent the wheel.
Mm-hmm.
And so I feel that audio, this goes along with what I just said about audio being an important discipline. I also feel that way in terms of technology and technological development. It absolutely deserves innovation and people pushing the boundary on tech, period. Just like it does in graphics. And so that's as much as I'll say on that.
Yeah, very interesting. Yeah, because if you're running a race by yourself, then it's not a very interesting race. But if you have other people that are pushing each other, and there's a bit of
Yeah, competition.
yeah, competition, I think that helps people to push
Yes.
their normal boundaries and push themselves to be better. That's really interesting. And do you think so? So there are all these tools that are coming out that, yeah, and if you look at middleware, that really make it probably where you can do audio programming and these things without even needing to touch a line of code. So do you think that it's more important than ever to have C++ experience and have coding experience and get yourself into that? Or do you feel that having that skill under your belt is maybe less important than it's been in the past?
It depends on what you want to do and what you're interested in. I would say in a world where everyone uses the same code base that's relatively black boxed, it's not that useful to learn C++. In a world where there's innovation and people driving things, where there's lots of different solutions, it's really easy to expand and extend existing code bases. Like Unreal Engine, one of my pillars is everything we build has to be something that, because all the sources available, that people can learn and use and extend. So I want to create code that is the ideal place for audio programmers to exist, like an audio programmer ecosystem. So both for, I deeply feel like this is something that needs to happen for audio, but also for my own benefit. Like, If but God forbid I decide to leave from Epic, I want to be able to continue working on the cool stuff that I've been working on outside. So I'm building APIs for potentially future Aaron 10 years down the road or something, right? You know, I want to create economic opportunities for audio programmers to build careers on expanding and extending the architecture that I'm working on now, right? Like seeing a Nicholas Furnell plugging his stuff into MetaSounds gives me tremendous, deep, and profound joy. That's the thing. Like the more people that do that, the more people working together, expanding and extending and driving the thing is the power, right? So in that world, C++ is very valuable. So it depends on what you want to do. If you're a sound designer, so there's a continuum, I would say, of technical skill, and all of that is valuable. So it's not like you want to say one thing is more valuable than another thing. If you want to do a cold economic analysis in terms of financial success, if you are skilled in something that fewer people are skilled in, then there is higher demand, and thus you might make more money. But I am not somebody who values things based off of that. Like money is just because you might make more money doesn't mean it's better or worse than something else. But if you are doing something that there are fewer people able to do, that drive and people want you to do that, that's called demand with limited supply. But ignoring that aspect, there's a continuum of skills, and each of them are valuable for the aesthetic quality of the experience that we're trying to make, right? And so if you're not very technical, you should, and that's fine, but you, because of the supply demand thing, there's probably more people who aren't technical, which means you need to be really freaking good at sound design, like the best of the best of the best, to have a chance of making money and surviving. Um, so that's sort of the calculus that goes into it. If you are not as good as a sound designer, it probably makes sense, or maybe you're not interested in becoming a good sound designer. It makes more sense for you to become more technical as you develop a skill set that there's more demand for. That's just for the economic thing. That doesn't mean it's better or worse, though. It's just harder to get a gig. It's just like the reality of it. Um, and in games, well, in any artistic endeavor, it has nothing. Games have nothing to do with it. Anything that involves media and technology, you need that continuum. You need somebody who's, and it doesn't. One person can express multiple
Hmm.
elements on that continuum, but that doesn't mean the continuum doesn't exist. Uh, but there needs to be that that thing. Like, okay, now I'm putting on my. If it's one person, it's like I'm putting on my technical hat. How do I deal with this fucking driver? There's nothing fun and artistic. And you're like, okay, now I'm done with that. All right, now I gotta fucking go and make some cool music. Okay, now I gotta put on my art, and you gotta be able to switch roles like that. It's possible for one person to be able to do all that and work together, and that's awesome. So there's no one hard rule. You should learn programming. It depends on what you want to do and whether or not you want to get a job.
Here's a maybe controversial question.
Yeah.
Do you feel that game studios in general expect too much from one person? And
Yes, 100%. For audio, absolutely.
yeah, because I've
That's not controversial.
yeah,
I actually sat down to write what I did recently, like a day in the life. Some internal stuff going on, and I was like, "Here's what I do." I was like, "This is probably 5 different jobs." This is probably 5 different jobs. I'm like, I don't know. I don't know if there's enough time in the day to do all the things that I do, but I'm trying. I'm trying. But that's true for probably that's true for a lot of people in games, regardless of the discipline. But it's absolutely true for audio. I definitely think because there's not can't specialize as much.
yeah. I remember a few months ago or a while back, I did a live stream with somebody from Audio Kinetic, and we did an introduction to Wise. I remember looking at that, and I was thinking, this is such a complicated piece of software. It must take it's like a doll, but times 100 in terms of the things that it can do, and
It's not like a DAW. We already talked about this.
yeah,
Whatever.
well, just in terms of the feature set of the different options and the different features, it it just felt like,
It's
and
complicated.
yeah, it's hella complicated,
Yeah.
and and not only that, you're thinking about more than I think that one nice thing about a DAW is for the most part we're thinking about two channels of audio, and in this you could be thinking about multiple or different types of audio setups, and I thought sound design. So you got to know a DAW. So you got to know a DAW to do sound design. You got to know recording practices. You got to know, uh, and then and then some of these job specs. It's like, yeah, it must have worked on a professional audio engine, and I just thought, wow, this is just a lot of
There's a lot of shit to learn.
yeah,
100%.
stuff.
It's not fair.
And a lot of stuff for one, and too much stuff for one person, in my opinion.
Absolutely.
I've, I've I've read some of these job specs, and I've thought I don't know any. I maybe know three people in the world that have all of these skills. Yeah, that can.
So
That, yeah,
so
yeah,
that
go
I'm,
ahead,
I'm
go
I'm
ahead.
glad you brought this. I'm
Yeah,
glad you're bringing this up because I think it's really important. Um, so for an indie game, they're often constrained where they're like, we they don't may not even think about audio until like years and years into development, and then like, okay, we need audio, and so that's one of the reasons why people use Wise a lot. And I don't think it's a good situation. Nothing against Wise, but like what happens is a studio is like, okay, now we need to get audio. Let's contract it out. The contractors, it may even be like a custom engine for the indie developer, and the contractor's like, okay, how do we want to do this audio? If it was like, here's a shitty audio engine written by one of our programmers in a couple weeks, or here's Wise, you'd pick Wise, right? And so already it's a huge advantage just from that domain. If you're using an Unreal Engine game, you may have a fully featured audio engine like us, but the same indie studio is contracting out a random, external, maybe even a really high powered, high quality external audio engine or audio team. There's a lot of companies out there that are awesome. I'm friends with a bunch of people there, and the really high powered ones learn all the tech. They can learn Unity. They know audio. They know native UE audio. But they then themselves subcontract with people, and sometimes those people only know Wise, and so then they might choose Wise because it's like a common language, it's like a lingua franca of audio. And all of this stems from this sort of problem that exists where companies themselves are not setting audio people up with success. So Wise is a great way for these companies to sort of not take audio seriously. And it's great. They sort of like it's like a business opportunity, right? Hey, audio is getting treated like shit. Let's make a tool that lets people have a quality bar and work in that environment, right? So, but Wise is still complicated, as you pointed out. Wise is not necessarily easy. It's complicated. It's just a common tool set that's used for across a lot of different engines. And so once you learn it, it's a very useful skill. People who are really good at Wise can just dive in on a project, do a bunch of shit in a couple weeks, and then leave, and then make bank. It's like how could you say no to that as a tool set? Um, but it's still not fair that you would expect one person to do the music, the sound design, all that stuff with limited time, limited budget, versus that same project that you might have seen that you look at how many artists did you hire? Why is audio always getting like the limited budget? Why is it not getting thought about? So my wife is a game designer and she's in a startup, and like and I'm always like, what are you guys gonna do about audio? And they're like, we're not gonna think about audio. I'm like, come on. If there's anything, at least you could appreciate audio. And she's like, eh. So it's like deep, man. It's deep. Yeah. So I feel it's unfair. So I don't know what to say. It sucks. It's not fair. You shouldn't be expected as an audio person to do everything. I cannot. I definitely think it's useful as an audio person to do everything. It just sucks that that's like the expectation across the board. Yeah, and then you get the same amount of money as like an artist who you contract out an animator and they just know animation. And you're like, okay, now that you're done with animation, can you do some cool shaders? Okay, now that you're done with the shaders, can you make some awesome like
Wow.
particle effects? Okay, cool. Now that you've done the cool particle effects, so there's no expectation that someone would be able to do that.
Um, what do you think the future of music listening is? I mean, we have these really awesome tools, these really um, awesome capabilities to develop procedural music, generated music. Do you think 5 or 10 years from now we'll be listening to songs that are just pre-recorded statically on Spotify, or do you think that there's ground to be broken in terms of the way that people are experiencing audio and music?
That's a really good question. I've had a dream for, God, I mean, shit, 25 years. When I first started getting into audio stuff, I was like, oh man, we could do this stuff, and like microphones recorded, and then as the audio comes in, put in a buffer, and then it like plays stuff back, so like as you're walking through the world, the things that you hear around you are integrated with music. Like I definitely think that that is something that's going to happen. It's kind of happened, but it hasn't in the past, but it hasn't really kicked off. There are people in doing stuff that I'm aware of in that world that I dreaming about like a distribution platform for procedural and interactive music. I think that's going to happen. I don't know if it's ever going to be. I think we live. I think the name of the game right now in our media landscape is heterogeny. Is that the right word? It's heterogeneous. It's not homogeneous. We have so many different ways to experience media. I mean, I'm still listening to Glenn Miller in the 40s. I just like my kids obsessed with it. We dance it every night. Like I think it's great. So that's never gonna disappear. We're still gonna have linear media. I still watch Netflix and watch movies, and then I'll go and play games. So it's just gonna get more bifurcated. And I think one new type of media that we'll experience, and I think it'll be more mainstream, is interactive and procedural music, like tuning, and it can get at an aesthetic level where you would actually want to listen to it.
Mhm.
I'm really into procedural music. Check out my SoundCloud. I
Yeah,
mentioned this.
SoundCloud.
So my SoundCloud, I'm joking, but I do have a SoundCloud, and I have a lot of music on there that's procedural. Here, I'll share it on my screen.
Like one thing that I
Like
always
a lot of this stuff is procedural. Like it's a recording, but it could have been something that was interactive.
thought.
Just because SoundCloud doesn't have a freaking platform, it's not a distribution platform for procedural music. But anyways,
Yeah, I always thought that in terms of procedural audio or experiencing audio in different ways, I always thought there would be something interesting in maybe having a medium where a, maybe there were a few variations of even in commercial music where maybe there were a few variations of a song that's been recorded, maybe alternate lyrics, different guitar solo, what have you, and that if you listen to the song twice, maybe you would experience it in different ways, or you'd have ways like almost like I don't want to say choose your own adventure, but ways.
just more like a game approach to mixing a thing.
Yeah, 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 yeah.
So, I mean, I think that's totally technologically possible. You could do that in Unreal Engine. The biggest issues with all those things is distribution. I think ultimately it's
How do you pack?
like yeah, how do you package it and how do you experience it? Like Spotify is like awesome, but it's like just streaming baked music, right? So you need something that's executing logic, executing code, um, and like basically loading DLLs and playing them and presenting interfaces. Because now you have to think about interfaces. Maybe it's just different every time, but you might very quickly you go like, well, I want to be able to customize it. As a user, I want to hear this and that. And then now you have to think about how to build the interface in a way that's easily consumable. Like games, like Steam transformed games because of distribution, right? Epic Game Store is trying to get on this on that in that world, but distribution is the key. And if you were to imagine like Steam getting turned into like an interactive music platform, it still wouldn't like the first of all, you don't want to like download a piece of music and experience it for hours and hours and hours. It's like a 3 5 minute experience and then move on, But you don't want to like install a game to hear music for 3 or 5 minutes.
Hmm.
And then if you expect it to be like an opera, like hours of experience, that's freaking enormous amount of content. And then it's basically a game, and then you're like probably would make no money, and so then there's the financial part of it, right?
Hmm.
So it's a complicated problem. I definitely think it's coming. Something like this is going to happen. I've been thinking about it for a while. Like I said, I know some people doing it,
Yeah,
um, and I think it's going to happen. It's just a harder space.
yeah, Yeah, it's interesting. Format, like what would the format be, or what would how
There
would
needs to be standards. Someone needs to make a platform. Is like, here's the interface. Here, like a VST plugin, right? It would be like some kind of interactive music plugin. You implement your code to this interface, drop it in, and then you could imagine a thing. There's ways to do it. It would someone just would need to someone would need to do it, and then get enough artists and content to like justify it. Get probably a lot of venture capital, adventurous venture capitalists, adventurous capitalists.
yeah. Or, or
uh,
or wouldn't it be cool to have at least part of your next your next hit song has one part of the track that's procedurally generated or something like that. That would
yeah,
be
and then who wrote it? Who gets the rights? Yeah, that's another thing is the rights on your music, right? I mean, I would say the algorithm is the thing. But like how could it depends on how procedural it is. But if it's like so dramatically different that you wouldn't be able to tell it's where it's from, then what the hell? How would you be able to prove it? I
hopefully
would be suspicious if procedural music gets to that level. But
hopefully it'll be the programmer, the developer that would get
yeah, that's right. Then we have like that's my fantasy. I'll be like the rock star. They'll be
yeah.
like, oh, there's Aaron. He wrote that algorithm. He's so good at writing algorithms.
Yep. I'm seeing it. Award-winning, platinum-selling.
Yeah, live shows. I just sit down and I start typing, and I hit compile, and I just go. Actually, live coding is a thing, and I have done it, and it's awesome.
Hmm.
In graduate school, Graham, I already mentioned to him. He was working with another friend of his on this live coding language that they wrote, built in Lua,
Hmm.
and we did a show when I was there where this is awesome. We had multiple projectors. There were three projectors. One projector was showing me programming. Another projector was showing him programming, and then another projector in the middle, which was the sort of graphic space that was getting generated from both of our code, and then you could hear the music. So it was like an AV audiovisual thing, and we're literally typing and coding, and people are watching us. I just want to say, it's like such an awesome idea of like coders as performers, and it's a whole thing. Live coding is a thing. If you haven't seen it, it's can be really cool.
Yeah, yeah. We had on the channel we had Sam Aaron who did. Uh, I'm ashamed that I've forgotten his platform, but he's actually written his own live. I mean, he's toured in the
Is that
past.
the dude who was you were with recent with Python? Oh, that
No,
was a different dude. All right.
no. Let me. I'm upset at myself.
SuperCollider is a great live coding platform, by the way. I love SuperCollider. Chuck is kind of built for live coding, and then one of the best live coding thing I've seen was with PD. This was at the International Computer Music Conference. I was there once. And they have a lot of crazy shows. It's very common to see live coding there.
Yeah.
And this dude,
Sonic Pi was the one.
Sonic Pi, cool. I think I've heard of that. So anyways, I saw this PD live coding patch where as he's writing his PD patches, like I'm not sure how he did it, the nodes started dancing and moving. Like his
What?
code was actually like synchronously dancing and moving to the music. So he's like writing, and it would go. He would like let it go, and it would go, and the nodes just start dancing. And it was the coolest thing I think I've ever seen. And I was like, oh my god, this thing is fucking awesome! Like
Yeah,
the code itself is the visual art, and the music was really cool. It's fucking great.
yeah,
Yeah,
yeah.
the creative coding community is truly my favorite community of people just trying to do crazy shit. They don't give a fuck. They're just like, let's make some cool shit.
Yeah.
I want that community to get into Unreal Engine. So if you're out there as a creative coder, hit me up. I would love to give you ideas or whatever. If you have any questions, like Unreal is like an ideal place for that kind of thing because of the context of it. It's not just MetaSounds or what we're doing for audio. It's like Niagara, freaking the whole animation, everything. The context of Unreal Engine and all it is, and having audio as a deep part of that is really exciting to me from a creative coder standpoint. Because right now people are doing cool stuff, but it's this like painful communication layer. It's like open sound control messages over to Maximus P.
Hmm.
It's like it's not great. And you couldn't. And the other problem is that in that paradigm, you can't distribute your work.
Hmm.
So, which again, distribution is key.
Mhm.
You know, so if you're doing all these crazy, awesome interactive installations, it's like you set it up at this one location. You know, you take a video of it so you can remember that awesome time that you built this cool experience, and then you take it down, and then you like put it on your resume, and like 20 years ago, you're like, man, that was so cool. I wish I could experience it today. Well, you can't. And so, if you did that kind of installation experience in Unreal Engine, you could. You could share it, and millions of people could experience your installation. You know, it's about distribution.
Yeah, and that sample accuracy and the real time nature that you
Yeah.
built into MetaSounds really feels like there's a lot of potential for something like that. Combine that with the animation, that feels really compelling.
Yes, I
Yeah,
agree.
great. Well,
It's all about the context. It's all about context.
that's right. And it feels like a good time to wrap up.
Yes, I'm really hungry. My
Yeah,
wife is making lunch, and I'm like smelling it, and I'm like, oh, I'm so hungry.
it's funny. I'm hungry too. I guess to wrap up, let's just plug Unreal Engine early access.
Yes.
How do you get it?
So go to the Epic Games launcher. Just type it. If you just type Unreal Engine 5 Early Access, Google will take you to all the things you need. We've got lots of docs already about MetaSound, so please check out the Early Access docs. We worked with the docs team on getting people on board, and it's based on Twitter. It seems like people are being able to figure it out pretty quickly, which is extremely gratifying. Um, I've been watching some live streams. So there's points of confusion that I think people are having. So hopefully we'll smooth it out. You can always hit me up. I lurk on the audio programmer Discord, so if you go join there and ping me, my moniker is minus Kelvin because I'm cooler than physically possible.
Because you're cooler than Fahrenheit.
No. Minus Kelvin, so it's literally impossible to be cooler than minus. It's not
Oh,
possible to be
yeah,
that cool. It's like absolute zero.
wow.
I want to remind you, I have a physics background, so that was a physics joke. Anyways,
Somebody out there got that.
somebody somewhere was like, "Oh God, that guy's such a damn nerd," and the answer is yes, I am, and I'm proud of it.
Yeah,
Uh, yeah, so just hit me up if you have any questions or if you want to complain. I'll be totally happy to spar with you.
yeah.
I'll soapbox on any of these topics if you want me to soapbox again. And yeah, I think it's great. I would love to see. Also, if you make something that's crazy and fun, tweet it out. Put hashtag MetaSound. I'll see it because I have it hooked up on my tweet deck, and I just like see what other kinds of crazy shit people are making. It seems to be big in Japan, by the way. I was really impressed with a lot of Japanese people tweeting out about MetaSounds, which is really
Hmm.
exciting. So I'm like following Japanese people now, and I like have a I don't speak Japanese, but I like translating tweets and having like building whole relationships through Google Translate.
That sounds so cool.
It's great.
Yeah. Yeah, and as Aaron said, you can find him on Twitter as well on minus Kelvin.
Yep.
And yeah, you can also find us on the Audio Programmer Discord as Aaron had mentioned as well. You can join there on the audioprogrammer.com/community. So yeah, we hope you enjoyed this talk. Yeah, please go grab it. I know I've already downloaded it, but I haven't had a chance to check it out yet. So I'm
Yeah, Josh, make a note and post it. Give a tutorial.
yes.
You should, and throw it my way, and I'll tell you if you're doing it wrong or whatever. You're probably not. It's probably, but just let me know.
So to make sure that I'm not doing it wrong, I'll probably show it to you before I actually.
Exactly. Or if you run into any problems, there's a couple gotchas here and there you might run into.
Yeah, I love it. We're
All
gonna
right.
cool. Thanks a lot, Aaron.
Yeah,
And
no problem.
thanks everybody for watching, and we will see you again soon.
Yes, absolutely. See y'all.
All right, take care.